Hey everyone, so we're gonna take an entire video and discuss one topic, which is the topic of polymorphism, and I'd like to take a whole video to just focus on this one topic because this is something that comes up a lot when it comes to object-oriented programming. I will tell you, a lot of my students have come back and from interviews, and one of the questions is, can you describe polymorphism? And so it's a question they like to ask in interviews, and it's an important concept to grasp in object-oriented programming. So polymorphism means, many forms. That's kind of um, what it's defined as. And so, how does that apply here? What does many forms mean? Well, the easiest one definition of polymorphism you should be familiar with at this point is method overloading. And so, there are many forms of a method when you overload it. And so one version, the most simple one, the easiest one is method overloading. That is a version of polymorphism. To give you an example, you call the sum method and you pass it, you know, uh, 3 arguments versus calling sum and passing it 4 arguments. These are two overloaded methods. So this method has many forms, and that's polymorphic behavior. But it definitely gets more complex than method overloading. Another kind of more simplistic one would be method overriding. This is another example of where a method has many forms. And so if you have a cat, c1 equals new cat, and you were to say cat.speak, this would cause one action to happen, right? Whereas if you had uh, a dog and you said dog.speak, this speak method would, even though they're both the speak method, depending on the object that it references, it's going to cause a different behavior. This is uh, also called, dynamic method binding is what this is called. Basically, you know, um, actually, I got ahead of myself with the dynamic method binding. I'm going to demonstrate that here in a little bit, so I'm going to put that down below. Because this isn't exactly dynamic method binding, that would be the third version, right? So if this is overloading is version 1 of polymorphism, overriding is version 2, then this dynamic method binding would be kind of a third way to implement polymorphism. And this is something that's new. This is what we haven't seen. So let me go ahead and I'll just code this example. I'll create a cat, a dog, and they both inherit from animals. So I'll code that up real quick. Go ahead and create an animal class, and an animal class is going to have a generic speak method. Oops. And a generic animal, we don't know the sound that it makes, so it's going to be, we'll just say it's kind of a silence when a generic animal speaks. But if we create a dog class, that dog extends animal, and I'm going to copy this method and paste it, you could see that this is overriding. So this is kind of going into the example that we were talking about, and the dog's speak is going to woof, right? And then we'll just create another class called cat, which will extend animal and meow. So if we're back in our demonstration, we can create an animal, a dog, and a cat. And to demonstrate now these would work. Our overriding example would work. But this dynamic method binding we haven't talked about, and that's the idea that a parent reference can reference any of its children. And so that's a little bit strange and a little bit different the first time you see it. So it's going to be a little bit different here. So, in this example, animal A1, and this reference variable A1 can reference a dog. So animal A1 equals new dog, and you could do this on 2 lines or you could do it on 1, just to demonstrate on 1. And when a parent class would reference a child class, we could A1.speak, and in this case, even though A1 is A1 references an animal, but the current instance, what it's currently referencing, is a dog. So now when we say A1.speak, you could see that A1.speak, this line here, this is dynamic method binding, and that it's really looking into the type of creature or the type of object that it's referencing currently. A1.speak in this case, will output a dog speaking woof, right? And then because cat is also an animal, we can change A1 to reference a cat. Very similar to what we did up top. So a parent object can always reference an instance of its child. And now if we were to do system out print line A1.speak, A1.speak in this case will output a cat speaking meow. Okay, so first you're going to see the woof, then you're going to see the meow from the cat. So this is a third version of dynamic method binding, of overloading, and really what it means is that this A1, this animal object, it can have many forms, meaning it can reference any of its children. So methods can have many forms, but objects can also have many forms. And that's the concept of polymorphism in regards to object-oriented programming. Here we have an animal object and it references a dog. That's one form. We can then change that reference variable to reference another child, like a cat. And then you have the methods of the cat class at your disposal, and the members of the cat class, once your parent references that child. And actually I just caught myself in a quick mistake, and I want to demonstrate the mistake that I said. I said here, now that A1 references a cat in this instance, okay, I said that this reference variable would have access to all of the methods of cat. That's incorrect. In both of these scenarios, A1 references a dog and A1 references a cat. You only have access to the methods of the parent. Well, speak is a method of the parent. That's why we have access to speak, and it will invoke the methods from the child. But let me demonstrate this a little bit further, in the sense that you do not have methods of the children when you have a parent object referencing a child. And so in this case, right now we've got animal that speaks, we've got a dog that speaks, and a cat that speaks. Let me demonstrate something that a dog can do that a cat cannot. And I'm sorry to all the cat lovers out there, but cats cannot uh, um, be. And you're looking at me funny. You're looking for what I'm going to say. Uh, there cannot be lovable, we'll say, right? So dogs can be lovable, cats cannot. So be lovable. I knew you were gonna cause me to mess up. Okay, and so a dog can be lovable, in which case it's just going to say dog cuddles with its owner. And cats typically don't. They typically snuff the owner, right? So we're going to return the dog cuddles with the owner. And that method is not a portion of cat. That is something that only dogs can do. Is that we can call this be lovable. Well, going back into my demonstration now, um, if you notice, I do a system out print line, and I were to say a1 dot. You see here in our methods that we have available to us, we have a speak because it's available in the parent, but there's no be lovable, right? That will be a compiler error. Whereas if we were to instantiate a dog in our normal fashion, and then, so we'll comment this out, then that's when we can say d1.belovable. There's our method right there. So I just want to be clear about what methods are accessible when you have objects that reference their children. You only have the methods from the parents to be able to work with, not the methods from the children, as I demonstrated right here with this compiler error. That's a method of the child, but because we have an animal A1 is a new dog, you only have the methods from animal available to call. Okay, so that's a brief overview of polymorphic behavior, right? Polymorphism means many forms, whether that's a method having many forms with overloading, or a method having many forms with overriding, or an object having many forms when you can reference a variable equal to one of its children.